if you go through this, last 10 years question paper, JEE Main, Advanced, Board, relation function plays an important role, and it is the backbone of calculus. So today our topic is relation and function. It depends on the basic property of set also, set theory. Okay. Now, what is set? We know set means collection of defined elements. Set is collection of defined elements. Okay, means set of natural number. If you get chair, table, fridge, set of furniture, so the element which are defined, which has some definition, their collection is called set. So set is collection of defined elements. You know that set, any set A is denoted by two, brace or second bracket, starts with second bracket, ends with second bracket. Suppose there are two elements. Elements are defined by commas. Elements are defined by commas. If there is no element, that means the set is empty set, empty set or null set. Okay, it is denoted by 5. Now let us take two sets of such type. Suppose there is a set A which contains two elements, 1 and 2, and another set contains two elements, 3 and 4. Now we'll find the Cartesian product of two sets. Cartesian product of two sets A and B is what? That will be denoted by A cross B. Okay, Cartesian product A cross B. Is it synonymous to normal product? No. This Cartesian product means how many ordered pair can be formed. Ordered pair means one will have a pair with 3, one will have a pair with 4, 2 will have a pair with 3, 2 will have a pair with 4. That is called collection of ordered pair. Ordered pair you got in coordinate geometry, where you got x, y form. X is independent variable and y is dependent variable. Now, if you get that order, means x and y, then this pair is called ordered pair. So Cartesian product of two sets is nothing but the collection of ordered pair. Now you see this x and y. See, the elements in set A are x, elements in set B are y. That means element in set A is called objects and elements in set B are called images. Okay? Suppose in set A suppose this is your house. Your parents are waiting for you, and suppose father and mother waiting for their son and daughter. So how many pair we can form? Son is studying engineering, daughter is studying medical, suppose. Now, one day, father has called son and daughter. In next day, mother has called son, then daughter. So, how many pair we can form in this way? 1, 3, 1, 4, 2, 3, 2, 4. So, if you consider that example with your match with this example with your daily life routine, then the thing becomes so simple. So these are parents are objects, means set of x, they are anxiously waiting for the result of their words. They are images, objects, images, they are y. So thus this type of relation we can form. So we have got the idea of Cartesian product, comparing this with a daily life simple example. Now, to get the concept of relation, you must have some idea of set theory of subset. What is subset? I know. I hope you know. Subset. Suppose what is subset of a set? Suppose there is a set S. It contains 5 elements. Another set T. It contains 2 elements. Okay. So how can I compare this to this? This comparison you got even in junior class in less than, strictly less than, or less than equal to concept. See, these 1, 2 elements in set T are also the elements of set S, but the set S has some more elements. So here T is proper subset of S. And how to symbolize it? This. T is proper subset of this. You can ask me that if this is proper subset, what is subset then? Like you are taught x strictly less than y, and if x strict less than equal to y. If you get that concept, here strictly less than y means there is no scope of equality, but here less than equal to y means there is a scope of equality. If you drag this concept in set, then it is called subset, and this is proper subset. Proper subset. Okay. So example of proper subset. Suppose natural number. This is set of natural number. Set of natural number. Set of natural number symbolically denoted by n. And W, set of whole number. Whole number. So how can we distinguish natural number and whole number? Whole number starts with 0 and natural number starts with 1. Okay, and they from 1, and this will start from 0 and go to infinity. So whole number has one more element than natural number. So I can say W is subset of n. You can ask me, how can you put equality sign? Obviously, whole number is greater than natural number at least by 1 point. See, suppose you have got a natural number. Suppose you have got a natural number, set of natural number from 1 to 10, and set of whole number that is also 1 to 10. Means 0 is excluded. Not all whole number is taken. In that case, whole and natural will become equal. They differed only by 0. Whole number got one more element, that is 0, which natural number doesn't have. So I can say this is proper subset. Whole number is bigger than natural number. Here, set of natural number is subset of, because there is a scope of equality. Or you can say S is superset of T. T is the subset of S. S is the superset of T. Got it? If you consider central government and state government is the subset of central government, and central government by administrative power superset of state government. Okay? So we will define now relation. So few minutes back we have taken this example which contains two sets. One has two elements 1 and 2, another has 3 and 4. So what is their Cartesian product? From 1 to B, A to B, the mapping is being done. So these are, I have just told you, objects. These are images. Okay. So A cross B, from X to Y, how many ordered pairs can be framed? 1, 3, 1, 4, 2, 3, 2, 4. That is A cross B. Suppose you have got 1, 3, 1, 4. Okay, it can be this can be happen. This father, mother, son, daughter. In one day, father has rang son and daughter. Okay. In next day, this relation, human relation, you can compare mathematical relation to human relation. See, father rang son and mother also rang son. Another set can be formed. Father rang son and mother rang daughter. See, in each cases, we have got a relation between objects and images. Okay? Object means parents. Images means their word. They depend on objects. That means they are the images. So, see, these elements are also the element of this. These elements are also the elements of this. These elements are also the elements of this.
Yes,
So
sir.
each of these R is the subset of A cross B. Each of these R is the subset of A cross B. So all these are relation from A to B. Relation from A to B. So how can I frame the definition of a relation? Therefore, R is a relation from set A to B if R is the subset of A cross B, denoted by R colon A to B. Hope you could follow.
Yes, sir.
Now, you observe three relations. In first relation, one object, two image. 1 goes to 3 and 4 as well as. In second relation, two objects, one image. And third relation, distinct object, distinct image. So this relation is one to many. One to many. One to many. Can you give one relation in your daily life of such type? See, in a classroom, suppose you are going to your school. In a classroom, teacher is teaching math. One teacher is teaching good number of students, means one to many. Understand? So that is
Yes.
one to many relation. Now, two students have got same marks. many to one relation. That is called many to one. Many to one. It is possible. Why? Because in an office, two or more than two persons can have same salary. In an exam, so many students can get same marks in one particular subject or in total. Or this is called one to one. Suppose you are not satisfied with your school teaching, then you are doing what? You are hiring one teacher who can come and teach at home one to one. Sometimes guardians are seeking, sir, please give my child one to one coaching. Suppose physics teacher is teaching this boy, chemistry teacher is teaching this girl. So one to one. Yes or no? This is
Yes.
called one to one. It is many to one. It is one to many. So these types of relation will get. Now, out of these three relation, last two will be called function. Why? In this case, suppose, I am telling you, in math, you don't believe on jugglery of theory always. Sometimes some silly example we have to take. The example which I should not give, but it happens in our society. Suppose one student has got 2 marks in one subject. How can it be possible? 2 marks in one subject. That means the marks which is got by the students have come by mistake, not by his performance. Yes or no? His or her performance. By
Yes.
mistake, he or she has got. But for to get these marks, uh, whether the guy spent time or not, we don't know, because one student cannot have more than 1 marks. So here marks is independent of labor, but here students can get same marks. That means here marks depend on the performance of the student. They have given, they have same IQ level, they are giving same level, they put same labor together, so they get the same marks. And distinct students have got distinct marks. That means obviously, talent, IQ and performance vary man to man, person to person. So here also marks obtained by two students are depending on the time spent for study for the student. So in these two cases, that y means in order pair x comma y depending on x. So these two things are called, these two relations are called function, and that is all three are relation, but that is exclusively true for relation one to many. Okay, so from this example we can get the definition of function also. So function is a relation from set A to B. If I told you that in each set A we will get objects, if objects in set A and images in set B are connected by one-to-one or one-to-one or many-to-one correspondence. One-to-one or many-to-one correspondence denoted by F colon mapping is being done from set A to B. Okay, so function is also a relation. Okay, if from set A to B, objects in set A and images in set B are connected by many-to-one or one-to-one correspondence, then we can say it is called function from A to B. A function which maps set A, the elements of set A, objects of set A to images in set B. Okay, that is the definition of function. So from here, one conclusion I can draw that all functions are relation but not the reverse. All functions are relation but not the reverse. Okay, hope you could follow it. The basic difference between relation and function you have got. If you have any doubt, without any hesitation, you can ask.
No doubt, sir.
Thank you. Now, see, suppose there is a set S which contains these elements 1, 2, 3, 4, 5, 6, 7, 8, 1, 9. You have to clarify whether it is function or relation. Function or relation. How to recognize that? You see the ordered pair x comma y. X goes to y. 1 to 2, 3 to 4, 5 to 6. So till now it seems to us 1 to 1 means function. 7 to 8, but the system is broken. Again 1 to 9. So here that 1 to 1 correspondence, that relation is broken. 1 to many has come. So it never be a function. It must be a relation. Okay, 1 to
Yes.
many. 1 as an object goes to 9. 1 as an object goes to 2. So it is purely relation. Understand?
Yes, I got it.
Now, that set of objects is called domain, and set of images is called set of images, not all images, set of images of those objects is called range, and set of images whose pre-image may or may not belong to domain is called codomain. Example, if you get stuck theoretically, example, you see there are two sets, set A, set B. Here, two objects are given. Two objects means two persons have bought ticket to go for Delhi. So once they avail Rajdhani, they have seen against their name there is a seat allocated. So the seat is allocated against their name. That is image, and this is called range. Okay, so range contains those image whose pre-image are there in domain. Understand? But in set B, there are other passengers also. Yes or no? Those passengers pre-image do not belong to the family of that two persons. Yes or no? So
Yes, sir.
that is codomain. So range is the subset of codomain. Sometimes there is a scope of equality that will be discussed in later, mainly in class 12, that 1, 1, on 2 type function, this range and codomain's relation will persist. Now, this function will be denoted in this manner. Y is equal to fx means what? Y is a function of x. It is denoted by fx or phi x, gx, with this notation. Now, it is not new. The concept is not new. See, when you got the idea of plotting a linear equation graph, suppose y is equal to 2x plus 3. You used to follow that concept of function, okay, in subconscious mind. We are not aware of function, but the role of function we used to maintain in junior class. How? We used to take 3 arbitrary value of x in solution table. Just recall your memory, x and y. X is independent variable, Y is dependent variable. That means Y depends on X. So Y is the function of X. Here what is the function? What is the function? How it is defined? 2x plus 3. Yes or no? Y is the
Yes, sir.
function of X. That you are taught in junior class. So we used to take 3 independent variables. Suppose 0. Then Y would be 3. X is minus 1. Y would be 1. X is 2. Y is 7. So we used to take 3 independent variables, and against it we used to get 3 dependent variables. So that, in subconscious mind, the role of function we had practiced in junior class. Yes or no?
Yes, sir.
Okay. So what we have seen, according to the change of this x means the value of y will be changed. Okay, value of y will be changed. Let us do some simple question based on this function. But still now, we haven't got the idea of different type of function. See, just wait. See, suppose in set theory, suppose 1 is an element, A is a set. Few minutes back we have got. You are quite familiar with the term. It is called belong to. 1 belongs to A. Okay, that is fundamental property of set theory. Now I will show you one sum based on this fundamental theory of function. Though it will be fundamental, but why it is so important, it will be disclosed in short while. Just wait for a while. Suppose you have got a relation, a function fx is equal to 2 to the power x by 2 to the power x plus root 2, where x belongs to R. R means set of real number. Now, then summation of f k by 82. What is k? K starts from 1, ends with 82, 81. k starts from 1, ends with 81. Okay? 4 options are given. √2, option B 41, option C 82, option D 81/2. Okay, there are 4 options. Now you have got the idea that if I bring some change in place of x, so these x and these x will also be changed. Yes or no?
Yes, sir.
And in class 10 level statistics, you got the concept of this summation sign. You are aware of this sign sigma. Sigma means summation. Summation means what kind of summation? It will start from 1, end with 81. Means I will put k1 plus f k2 by this, k3 by this. Okay, so this indicates the summation which starts from k1, ends with the k is equal to 81. Okay, let us try. See, first of all, as a side note, I am expanding the summation. I am removing the summation sign. How? I am putting 1 f1 by 82 plus k will be increased by 1 f2 by 82 plus f3 by 82 plus f4 by 82. How long should you write? It can go up to what? Last term f81 by 82. Second last term, for your convenience you can write second last term f80 by 82. You can ask me, what is the use of all this? What is the use? See, I am getting a connection between these two. What connection? See, that f81 by 82, roughly you try, f81 by 82 means instead of 81, I can write 82 minus 1. So, 82 by 82, 1 minus 1 by 82. That means, if I am able to express it as 1 minus 1 by 82, so I can let it as x. So, that will be 1 minus x. Yes or no? See, that is x. Suppose 1 by 82 is x. So, what about 1 minus x? 1 minus 1 by 82 is 81 by 82. So, I can make a pair. Yes or no?
Yes, sir.
But what privilege I will get? See, now I will try to simplify the given function. 2 to the power x, 2 to the power x plus √2. You put 1 minus x. So here x will be replaced by 1 minus x. You will get what? This part, laws of exponent, means a to the power m minus n, a to the power m by a to the power m, 2 to the power 1 by 2 to the power x, 2 to the power 1 by 2 to the power x, and root 2 means 2 to the power half. So again, more simplification is required. And what is that simplification? See, we have nothing but to take, the LCM. 2 plus what can I cancel? 2 to the power x I can cancel. Okay. Now, from denominator, maximum what can I take common? In open I, what seems to you common? Here we have 2. Here 2 to the power half means root 2. I can take root 2 common. So if I take root 2 common, what will be left for me? Root 2 plus 2 to the power x. Now, root 2 and 2 will get cancelled. You will get root 2. So, that will give you root 2 plus 2 to the power x. Now, what benefit you will get from that derived value? I will add fx and f1 minus x and see the outcome. Fx plus f1 minus x, that is what? 2 to the power x plus root 2 So if I add, what will you get? So numerator denominator get cancelled 1. So we have got fx plus f1 minus x is equal to 1. Could you follow this?
Yes, sir.
Now how that result will play an important role here? How that result? See, here in this clubbing, suppose in your school, in practical, physics practical or computer practical, teachers are asking you to make a group. How? Roll number 1 and 81 will be clubbed. 2 and 80. See, denominator is 82. So 1 and 81 also will give you 82. Roll number 2 and 80 will be clubbed. Roll number 3 and 79. In this way, roll number 31 and 41 also make a group. But what about roll number 40? Roll number 40 will have no group. Roll number 40 and 42. Okay. Roll number, what about 41? See, if you call roll number 41 twice, that means, there is a repetition. Yes or no? One student is being called up twice. Yes or no?
Yes, sir.
देखो, roll number 1, 81. A group. Roll number 2, 80. Second group, 3, 79, which is not mentioned. Another group. In this way, when the roll number is coming closer from beginning and end, 39 and 43, 40, 42. But in case of roll number 41, he or she will remain alone. Okay, very odd looking. All are in group. One student remains alone. That means who is that student? he or she is not student but teacher. Yes or no?
Yes, sir.
Yes. So you club them. F 1 by 82 plus F 81 by 82. That will frame one group plus F 2 by 82 plus 80 by 82. That will frame another group plus F 3 by 82 plus F 79 by 82. Another group, the series is on, and once F 40 by 82 plus 42 by 82. All group. How many times? See, there were 1 to 81. 1 to 81 students. One student is taken out. Who? That roll number 41. Yes or no?
Yes, sir.
Now, instead of this, I can write 1 by 82 plus F 1 minus 1 by 82 plus F 2 by 82 plus F 1 minus 2 by 82. Dot, 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 dot. Okay? Yes or no?
Yes, sir.
And there were, see, 1 to 81 means total 80 students. Yes or no?
Yes, sir.
80 students. But 2 students will form one group. If 2 students will form one group, so 80 students will got 40 group. Yes or no?
Yes, sir.
So each group's value is what? You have just got. See, f x plus f1 minus x is 1. Yes or no?
Yes, sir.
So this is up to 40 times. And here 41 and 82 cancel, f half. So this is 1, this is 1. 1 repeats 40 times. 1 repeats 40 times. So I can write 40. Yes or no?
Yes, sir.
1 plus 1 plus 1 up to 40 times. What about f half? In place of x, you put half. 2 to the power half by 2 to the power half plus 2 to the power half. In place of x, I have put half. So 40 plus 2 to the power half, 2 into 2 to the power half, cancel. 40 plus half, 81 by 2. Option D. This year JEE 2025 question on this fundamental function property. We have not started. any type of function yet, but only x is replaced by some value. Only on that fundamental concept and summation property we have got a sum in JEE main. This type you got in JEE Advanced 2020 also. We will discuss in later. First, you tell me you could follow this sum or not.
Yes, sir, I can.
Good. Now, different types of function we'll discuss. Types of function. Like, odd even function, then periodic function, modulus function, greatest integer function, logarithmic function, exponential function, signum function, and so on. First, odd even function. Odd even function. See, if fx is equal to f of minus x, means in x, if minus is absorbed, minus fx. Odd function. Example, suppose you have got y is equal to x square. Obviously, it is function of x. So, I am replacing x by minus x. So, this x also be replaced. Will this minus sign remain? No, it will be absorbed because power is 2. So, f of minus x is equal to x square. So, we have got example of even function. One trigonometry example. Suppose Just wait. One trigonometry example, say f theta. Cos theta. So you replace theta by minus theta. Minus is absorbed. So it is a trigonometrical example of even function. Now, odd function, x cube. Will this minus sign persist? Yes, because power is odd. So it is odd function. One trigonometric example of odd function, odd function. So this is the basics of odd and even function. Next, modulus function. Sorry, periodic function. We have mentioned, so odd function is over. Periodic function. Periodic function. If then fx is periodic with period lambda, means what is periodic function? See, by every interval you are giving some increment in x, but even after giving increment, fx will remain same. Then the function is called periodic function with period lambda. One example, let f theta is equal to sine theta. Now sine theta means once trigonometry is involved, then each quadrant's angular value will be pi by 2. So let us give increment of pi by 2 in theta. Once you get increment, give pi by 2 increment in theta, that theta also be incremented. It will be cos theta. Did I get Did I get f theta return? No. It is not f theta. So pi by 2 is not the period. Therefore, pi by 2 is not the period of f theta. Okay. Then keep on increasing theta by pi by 2 in this way. You give pi increment in theta. So in case of sine, this is also incremented. Minus sine theta. So had this minus not been there, had this is not been there, I would have said that f theta is constant, but no, it is minus f theta not equal to f theta. So pi is not period of sine. Now let us give pi by 2 more increment, means theta plus 3 pi by 2 sine 3 pi by 2 plus theta. It lies where? Pi by 2, fourth quadrant. Sine will be changed to cos theta, not equal to f theta. So 3 pi by 2 is not the period of sine theta. Now give 2 pi increment. Pi f 2 pi plus theta. That means sine 2 pi plus theta. That means by the rotation of 2 pi and theta more, it will come back again to the first quadrant where sine is positive, or everything is positive, and I will get back sine theta again. So theta. So what we have observed, therefore f theta plus 2 pi is f theta only. So 2 pi is period of sine theta. Understood?
Yes, sir.
You can ask me, why 2 pi? Why not 4 pi? Because 4 pi plus theta is also sine theta. 6 pi plus theta is also sine theta. I will take the least one. Okay? In the same manner, period of cos theta will be similarly. In case of cos also, we will get period 2 pi. Cos theta, sec theta have period 2 pi. Tan will be tan theta again. Suppose this is theta. If you take tan pi plus theta in third quadrant, you will get back tan theta. So tan theta and cot theta have period pi, and we have just got sine and cosec have period 2 pi. Suppose you have got two function in division, sine theta by tan theta. Its period is 2 pi. Its period is pi. What we will do with that? We will divide the period also? No. In that case, we will take the LCM of the period. LCM of the period, that is 2 pi. In case of division, also that will, in case of addition, in case of difference of two function, the same property will be on. Now students get confused if they get sums like this. F theta is equal to sine 3 by 5 theta. Means instead of straight sine theta, there is 3 by 5 theta. What will you do then? If you go with normal 2 pi period, it will give you nothing. Why? You see, if you consider, okay, sine theta's period is 2 pi, this sine of this thing, that period is also 2 pi. Okay, you add 2 pi and see the outcome, whether you can reach to any conclusion or not. See, 6 pi, 30, 6, 216 degree plus 3 theta by 5. So we have not got the angles part in terms of 90 degree. So we can't come to any conclusion. So this method is not right. So I am giving you one shortcut trick which you can follow. See, we have come to know period of sine is 2 pi. What is the coefficient of pi? 2. Yes or no? 2.
Yes, sir.
Now you tell me, with 3 by 5, what to multiply to get 2? If I put 10 by 3, that will give you 2. Yes or no?
Yes, sir.
So period, its period 10 pi by 3. You can tell me, you are saying this and I will accept. Okay, then you check f theta sine 3 by 5 theta. So f 10 pi by 3 plus theta sine just multiply. See, 3, 3, 5 and this thing will be cancelled. 2 pi plus. So it will be rotated, angle is being rotated and come back again to the first quadrant. So sine 3 theta by 5 means f theta. So what is the period? 10 pi by 3. By that trick, we have come to know. Got it?
Yes, sir. Got it.
Similarly, suppose you have got those who do not know this trick. Suppose 5 by 4 theta, tan. Those who do not know this, they will fumble. Now, in case of tan, period is pi. With pi, we have what? What is appended with pi? 1? Yes or no? So,
Yes.
with 5 by 4, what is to be multiplied to get 1? 4 by 5. So, its period is 4 by 5 pi. Understand?
Yes, sir. Got it.
Suppose you have got a function like this. Find its period. See, I have given you the shortcut trick. Now, by using that shortcut trick, you can get the period of the numerator as well as denominator. In numerator, with 3 by 4, what to multiply to get 2? 8 by 3. Yes or no?
Yes, sir.
So, period of numerator 8 pi by 3. So, its period is 8 pi by 3. Is in denominator with 3 by 5. What I can multiply to get 5 by 3? Sorry, 1. Five by 3. So, period of denominator 5 pi by 3. So, its period is 5 pi by 3. But these two functions are in division form. So, their common period LCM of 8 pi by 3, 5 pi by 3. Okay? LCM of 8 pi by 3 and 5 pi by 3. That means LCM of numerator HCF of denominator 8 and 5 numerator 45 by 3. What is the HCF of 3 and 3? 3 itself. So
Yes, sir.
45 by 3. So that is a purely JE level preparation. Those who had that concept trick, they can follow. Another type of periodic function you may define. What is that? Suppose fx is a periodic function satisfies f plus 1 plus f minus fx plus 1 plus fx minus 1 is equal to root 3 fx. Then period of fx is what? Option A 4, 8, 12, none of this. Now, for your own convenience, you can write the definition of periodic function fx plus lambda is equal to fx. You observe here two functions are involved with period lambda. There is no minus sign, and with fx apart from 1 there is no other coefficient. But here three functions are involved with root 3 as one of the coefficient of fx, and there is a minus sign. So our role is what? We will convert this 3 functional value to 2. I will remove this minus 1. I will remove this root 3. Then I can say it is a periodic. Then only I will get the period. So that is our role. So you write the equation. Now you can tell me what is x. Here x is variable. Here x is variable. So what is the meaning of variable? In place of x, if I wish, I can put any value. So our main role is to replace minus sign from here. To how to remove this minus 1? I will bring plus 1. So you write in this way, replacing x by x plus 1, we get what we get. In place of x, I will put x plus 1. In place of x, I will put x plus 1. Okay. So what does it give us? Nothing but cancellation of this 1. So you have got f x plus 2 plus fx is equal to root 3 fx plus 1. Root 3 fx plus 1. Now this is denoted by equation number 1. This is by, and from here one thing I can do. See, between these two, what is the connector? See, fx plus 1. You did, substitution method in class 9 linear equation. Means from one equation we used to extract the value of y and we used to put it in other equation. Okay, so same thing, same concept, we will do that. We'll extract the value of fx plus 1. What is fx plus 1? Fx plus 1 is root 3 fx minus fx minus 1. That is leveled by equation number 2, and that value will be dragged here. Okay, in place of this, I will put that value. Understand? So that is the connector. That is the link. So this is equation number 3. So you write joining equation 2 and 3, we get what we get? fx plus 2 plus fx root 3. Instead of this fx plus 1, you write this thing, root 3 fx minus fx minus 1. So what benefit we'll get? Are we at all benefited by this substitution? Let's see. Root 3 into root 3, 3 minus root 3 fx minus 1. So to avoid that minus sign, I will bring this in left hand side. And that fx to be taken in the right hand side, thrice fx minus fx twice fx. Now, after reaching this stage, we can get a connection. Why? Because in equation 1, in right hand side, we have root 3 fx, and here root 3 fx minus 1. Had it been root 3 fx, then we would have connected this equation to that equation. So again, now we know the mechanism how to change the variable. Replacing x by x plus 1, we get what we get. See, after this stage, in place of x, I am replacing x plus 1 again. So, f in place of x, x plus 1 plus 2. Here, root 3 fx plus 1 minus 1, it has become fx is equal to 2f x plus 1, and that equation is labeled by, previously we could reach up to equation 3, now 4. Now what is the connection between equation 1 and 4? In equation 1, right hand side we have got root 3 fx, and in equation 4, left hand side we have got root 3 fx. So then we can connect 1 and 4, and you write joining 1 and 4, we get this is fx plus 3 plus this will remain unchanged. Instead of root 3 fx, f x plus 1 x minus 1. Then how we are privileged? Root 3 removed. Now change this to right hand side. Hope you could follow. It is one kind of riddles.
Yes.
Okay. Jigsaw puzzle. Twice fx plus 1 minus fx plus 1, only fx plus 1. Now we are in the verge of conclusion. This is equation number 5. Now x plus 1 is the variable I have got in right hand side. Our role is to bring x plus 1 in left hand side. Replace x by x plus 2. So in place of x, x plus 2 plus 3, x plus 2 minus 1, fx plus 1. So I can connect x plus 2 plus 1, fx plus 3. That is equation number 6. What is the relation between 5 and 6? You see, here also you are getting fx plus 1, fx plus 1. So we can combine them. We can combine them. And what can I write? Joining 5 and 6, we get f x plus 3, sorry, f x plus 5, this is. Instead of this fx plus 1, you replace this. from both sides, I can cancel. So from 3 equation, I am able to convert it to 2. So I can write if x minus 1 is equal to minus fx plus 5, still there is a minus sign inside the function. So now we have had the knowledge that if I replace again by x plus 1, then we get what? In place of x, that will be x plus 6 plus minus. So had this not been there, by closing your eyes, we would have told, by closing our eyes, we would have told 6 is the period, but no, minus sign is there. So we are just one step behind from the final conclusion. Replace x by x plus 6. What will you get here? Minus x plus 6 plus 6, x plus 12. What is fx plus 6? Minus fx, because fx is minus fx plus 6. Minus fx. So, at the end, we have got if x plus 12 is equal to fx period 12. Okay? Understood this sum?
Yes, sir.
So this sum is really interesting. This sum, we are flabbergasted by this, gobsmacking. If you go through this type of sum, one day maths will become your everyday's bread and butter. So today we have started relation, function, 2 topics of function is taught. It is important thing. I will encroach a little bit extra time for this chapter, because function, limit, differentiation, so many things are there that will actually, tentacles of mathematics will sap the student if they don't get the flavor of this. So I hope up to this stage you have understood. You follow the class again, you see the recording. I'm telling all of you, you see the recording,
Okay.
and this, I think this video will help you in your preparation. So next day we'll discuss something more of different function. Till then, goodbye. Thank you. See you in the next class. Goodbye.
Thank you, sir.